So in this video, we are reviewing linear functions. Now, as we've done in previous years and previous content, we have two ways that we can express linear functions. One is in gradient intercept form, which, as the name suggests, we can read off the gradient m and the y-intercept. So this form y equals mx plus c is our gradient intercept form, or we can express it in general form, where we have everything on one side equaling to 0 on the other side, where a and b are the coefficients and c is our constant. Now, we're going to, in example 1, sketch each linear function by finding its x and y intercept. So we have to remember two things: that to find the x-intercept, this occurs when y equals 0. So we can find the x-intercept by substituting in y equals 0. That's what we're going to do now. So x plus 2 times 0 minus 6 equals to 0. Now, the 2 times 0 just cancels out to give us 0. And we can rearrange x minus 6 into x equals to 6. So our x-intercept is 6 here. And we remember that to find the y-intercept, we set x to equal 0. So 0 plus 2y minus 6 equals to 0. So we can add the 6 to the other side and then divide by 2. This gives me y equals to 3. So we have our x and y intercept here. We're going to do the same for the second one. We find our x-intercept by setting y to equal 0. So I have 0 equals x minus 3. So x will equal to positive 3. For my y-intercept, I'm going to set x to equal 0. So y equals 0 minus 3. So the y-intercept is negative 3. So now that we have the x and y intercepts, we can sketch the two graphs. So first one, I'm going to do in red. The x-intercept is 6. So 1, 2, 3, 4, 5, 6. And the y-intercept is 3. 1, 2, 3. Now we just draw a line through these. Making sure they're passing through the 2 points, and that's just going to continue. Let's label that as well. So this is my graph of x plus 2y minus 6 equals 0. And my next line, the x-intercept is 3, and the y-intercept is negative 3. Now I'm going to draw this, connect the dots, and just extend the line through. And I'm going to label my line too, so I get this being y equals to x minus 3. So it's saying to estimate the point of intersection in part B. I can see that this point of intersection occurs right here, and this is the point 4 and 1. Okay, so a couple more that we're going to do. We are going to sketch a couple more lines, and we need to decide which of them is not a function. Now, our first one is going to be y plus 2 equals to 0. Now, if we rearrange this, we can see that y equals to negative 2. Now, this is a special type of line. If we think back, this is a horizontal line, which is going to look like this. If we have our origin here, remember our horizontal lines pass through that particular value. So y equals negative 2 will pass through y equals negative 2, and it will continue on all the way through here. This is my line, y equals to negative 2. Now, this graph, I can see it is a function because it will pass the vertical line test. So anywhere I draw a vertical line, each one x value produces one y value. We have no points where we have two x coordinates being the same. Now for part B, we're sketching the line x minus 3 equals to 0. Now if I rearrange this, I get x equals to 3. Now for this particular one, remember that is going to be a vertical line, so passing through 3 in the x So I get x equals to 3. Let's actually just label in the axes. Now I can see that this one, it's a relation, but not a function. The reason why is because it fails the vertical line test, because it quite literally is a vertical line. So by just looking at it, we can see it fails. All of these coordinates share the same x coordinate of 3. So this one is not a function, it's a relation. So just labeling these in. The first one is a function. Second one is not a function. And the third one, we're looking at the line x plus 2y equals to 0. So I want to draw this line really quickly by finding the x-intercepts and the y-intercepts. Now, x-intercept happens when y equals 0. So x plus 2 times 0 gives us 0. So x equals 0. My y-intercept occurs when x equals 0. So I get 0 plus 2y equals to 0. Y equals to 0. Now, both of these, if I draw this up, both my intercepts are the same. Now, keeping that in mind, we need to get some idea for how it actually behaves. So here we just know that both share the same x and y intercept. It'll pass through here. But just knowing that it passes through the origin is not enough, because we can't really tell how steep the actual graph is. We don't know what the gradient is. So in this particular case, it's beneficial to rearrange this into gradient intercept form. So here I want to make y the subject of the equation. So 2y is going to equal to, I can subtract x from both sides, and now I can divide by 2. So y equals negative a half times x. So we know that this is going to be a point here, but the gradient is negative a half. So that means when I go up 1 in the x, I go down by half in the y. And that same thing is going to continue in this direction, and then up here also. So joining a line through, I have now my function. Let's label it. Y equals negative a half x. And I know it's a function because it passes the vertical line test. So anywhere here that I want to draw a vertical line, I can see that it will only pass through the graph once. Anytime it happens just once, not more, we can say that it is a function. So this graph is a function. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.